Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
This program covers the Cameron Model D Annular Blowout Preventer, which has been made in sizes from 7 1/16 inch 3,000 pound through the 13 5/8 inch 10,000 pound working pressures. Later models and higher working pressures are covered by additional programs. The Cameron D Annular Blowout Preventer is the result of years of research and development. This design provides a tough packing element that features superior life and ease of replacement. Most DBOP sizes and working pressures are shorter in height, with less weight than other annular preventers available. It also requires less fluid to operate, allowing rapid response to closing and opening functions. The D preventer is simple to use, easy to maintain, and has an operating system that can be completely rebuilt or replaced in the field. The Cameron D Annular Preventer complies with API and NACE specifications and is suitable for H2S service. The operating system is protected by a dual lip seal and vent configuration, which eliminates the possibility of well-bore pressure entering the operating system. Should one of the seals leak, either well-bore or operating fluid will vent out these holes, relieving the pressure. High-strength polymer bearings prevent metal-to-metal contact between all moving parts to minimize seal wear and eliminate galling. Wiper rings minimize external and well-bore contamination of mating surfaces. From a functional standpoint, the D-packer and operating system eliminates the undesirable effect of well-bore pressure over-energizing the packing element. The self-energizing effect, present in some annular preventers, can cause rapid deterioration of the packer during use. To better understand the operation of the DBOP, it is important to gain a basic understanding of the components that make up the complete assembly. We'll first get familiar with the major parts and their correct names. The Cameron D Annular Preventer consists of only 5 major sub-assemblies, which are easy to maintain and remove when necessary. These are the D-packer, the donut, the quick-release top, the operating system, and the body, with various open, close, and vent ports. Lock ring access ports are also provided. The D-packer is proven over many years of shop testing and extensive field use. Dependable service and long life is assured. This packer is made of special nitrile rubber, which is suitable for H2S service and may be used with oil-based mud. Other compounds are available for low temperature and other extreme service conditions. Shop and field testing has proven this packer to have outstanding wear resistance, which provides long life and reliability. This is largely due to the patented metal inserts, which are molded as an integral part of the packer. These inserts, made of alloy steel, are shaped so that when bonded into the rubber, they will remain in metal-to-metal contact with the adjoining inserts to provide a continuous barrier. In all positions, open, closed on pipe, or closed on open hole, to protect the rubber and minimize extrusion. The unique shape of these inserts causes them to move inward on a spiral pattern, as the packer is forced to the closed position, providing a barrier, both top and bottom, in all positions from open to full closed. Here the packer is in the full open position, with the inserts in solid contact with one another. As you can see, when closing pressure is applied to the piston, a force is exerted through the pusher plate to the donut, horizontally distributing the force around the outside of the packer, moving both the packer and the inserts inward to close around the pipe. Here the inserts have moved along a spiral path toward the center as the packer is closed on the pipe. In an emergency, the packer may be closed on an open hole. Again, the inserts have remained in metal-to-metal contact, containing the rubber against extrusion. The packer receives its closing force from the donut. The donut is a large circular ring of soft synthetic nitrile rubber molded in a solid piece, without any inserts. It seldom needs replacing and outlasts the packer by about 3 to 1. The top surface of the donut is shaped to fit the inside profile of the top piece, and the bottom to fit the pusher plate. When closing pressure is applied, the donut converts the upward piston force through the pusher plate into a horizontal movement of the donut, equally applying force all around the outer diameter of the packer. This force pushes the packer to the center of the preventer bore, sealing the annulus area around the pipe. After removing the closing pressure, the application of opening pressure will release the upward force from the donut, permitting the packer to return to its normally full open position. This is the quick-release top assembly. It remains a sub-assembly when it's unlocked and removed from the body. It consists of the following parts: the top, shown in purple, the actuator ring, shown in yellow, the split lock ring, shown in light green, the 4 actuator screw assemblies, and the top trash seal, which prevents mud and debris from getting into the locking mechanism. The quick-release top provides an easy means for the replacement of the packer. As shown here, it's firmly locked into the body of the BOP by this split lock ring. The locking teeth are formed by concentric grooves, machined into the body and the split lock ring. These locking teeth equally distribute the load exerted against the top by the operating system and well-bore pressure. The quick-release top is easily removed by unlocking the split lock ring. This is accomplished by rotating the actuator screws counterclockwise, raising the actuator ring, permitting the lock ring to move inward as it returns to its originally machined diameter. This disengages the locking teeth from the body, permitting easy removal of the quick-release top from the body cavity. This is the operating system. If it becomes necessary, the operating system may be easily removed from the body as a subassembly. It consists of the following parts: the pusher plate, shown in orange, is in direct contact with the donut and is bolted to the operating piston here. The support plate, shown in tan, covers the inner cylinder studs and nuts to provide a solid support for the packer. The inner cylinder, shown in dark green. The outer cylinder, shown in light yellow. The piston, shown in red. The piston, a single cylindrical piece, provides the force that is applied to the pusher plate and donut to close the packer. By applying hydraulic fluid pressure through the close port to the bottom of the piston, upward force is applied to the pusher plate, causing the rubber donut to move horizontally toward the center, applying equal force all around the outer diameter of the packer, forcing it to the closed position. Applying hydraulic fluid pressure through the open port to the top of the piston pushes the piston down, releasing the upward force on the pusher plate and donut, allowing the packer to return to its full open position. As previously stated, the operating system can be removed from the body as an assembly. All metal parts, all the seals and bearings, remain together when it's lifted from the body. An important feature of the D preventer is that it's also possible in the field, with the help of a Cameron serviceman, to remove either the inner or outer cylinder separately. All cylinder and piston seals or bearings may be replaced at this time. Under normal drilling conditions, we recommend 1,500 pounds operating pressure. With the exception of stripping operations, this pressure may be used throughout the life of the packer. Remember that when stripping pipe through a closed annular preventer, the closing pressure should be as low as possible and still maintain a seal that leaks slightly so as to lubricate the pipe as it moves through the packer. For the Cameron D preventer, this approximate closing pressure can be arrived at by using the formula P, which is stripping pressure, equals 0.25 times the well pressure plus 500 psi. An example would be, if your well pressure is 1,500 psi, then P, which represents stripping pressure, equals 0.25 times 1,500 plus 500, which equals 875 psi. With a clean, oily rag, lubricate the top and outside of the donut and the packer. We're now ready to prepare and reinstall the quick-release top. Install the slings in the lifting eyes and raise to working height. Wipe the inside seal ring groove clean and dry. Install the top ID lip seal dry, with the lips pointing up. Lubricate all inside and OD surfaces with a clean, oily rag. Spray oil behind the locking ring. Care should be taken to use only minimal amounts of grease. Excessive amounts of grease can cause difficulties in locking the quick-release top in place. Now move the quick-release top into place. Center it over the bore of the preventer body. Lower slowly, ensuring that it is lowered in an even and straight manner. Continue to lower until the quick-release top is fully seated. The actuator ring is now approximately 2 inches above the body. By looking into the lock ring access ports, check the alignment of the locking ring with the grooves in the body. These teeth must line up as shown before starting to lock the top in place. Rotate the actuator screws clockwise in pairs of adjacent screws as shown. Turn each screw a few revolutions at a time until they require additional torque. Then move to the other screws and continue the procedure until the actuator ring is essentially flush with the top of the body. The quick-release top is fully locked when the actuator screws have become tight, indicated by application of approximately 100 foot-pounds of torque, with no further movement of the actuator screws. The top trash seal must now be essentially flush with the body. Pack the cavity around the head of each actuator screw with clean grease. Then close the access flaps. Use a rubber mallet to ensure a tight closure. At the same time, hammer around the ID and the OD of the trash seal to make certain it's sealed against the top and the body. Now let's check the preventer for proper operation. First, connect the hydraulic clothesline to the close port, or reinstall the pipe plug. Stand a short joint of 3-inch to 7-inch OD pipe in the preventer bore. Apply 1,500 pounds close pressure. When the packer is closed around the pipe and the fluid stops flowing from the open port, watch the open port for 2 to 3 minutes. At the same time, check the vent ports. There are 4 vent ports around the outside of the preventer body. And 4 vents in the underside of the body, just above the bottom flange or hub. If there is a continuous flow from any of the ports, there is an internal seal leak. Refer to the D Maintenance Manual troubleshooting section. If there are no leaks, zero the close pressure and again remove the hydraulic line or the pipe plug from the close port. Connect the hydraulic open line to the open port or reinstall the pipe plug. Repeat the test we have just performed by applying open pressure. And again, observe the close and vent ports for leaks. If there are no leaks, zero the open pressure. And reconnect the hydraulic line or reinstall the pipe plug in the closed port. Alternately, apply open and close pressure several times. Observe the packer movement during these tests for proper function. The normal operating pressure is 1500 psi. Operating pressures up to 3000 psi may be used to function a new or a cold packer during winter operations without any damage to the preventer. If the preventer is on the well or a test stump in the shop, a pressure test of the packer may also be performed. Never test your preventer at a pressure greater than the rated API working pressure. Refer to the D manual in the section on pressure testing, or follow the normal rig procedures. To review what we have covered, remember to get all your tools and parts together that will be required before you start. Clean your work area. And make sure that you have the proper slings and handling equipment. Follow the recommended procedures and work safely. You may want to review this program several times to make certain you have the steps clearly in mind so that you can perform the packer change-out safely and in the shortest possible time. Additional programs on the Cameron D Annular Preventer are available covering Introduction and Operation, Packer Change-Out in the Field, Procedure for Removal, Disassembly, and Reassembly of the Operating System. If you have any unusual problems, refer to the Cameron D Annular Preventer Operations and Maintenance Manual, or call a qualified Cameron service representative who's already ready to help.